Hello everyone. This presentation is about our bot called KAWACH. Table of contents. First, we are going to discuss about the problem statement and then the solution and approach that we have taken. And I will show you the 3D model of the prototype that we are working on. Let me first just set the context. Indian farmers face a big challenge of weed management, where they try to do manual weeding process in which overspreading or underspreading of the herbicide could result in 30 to 40% loss of their crops. Wheat causes an annual economic loss of 92,000 crores in India. The major crops that are affected are Kharif 25 to 26% yield loss and Rabi 18 to 25% loss. The manual weeding process is highly labor intensive and shortages plus rising wages make traditional hand weaving increasingly impractical for many farmers in India. Losses may vary widely by crop types like rice, wheat, maize, soybean, pigeon pea. They all can face significant yield loss without timely control. Precision and timing are the difference between marginal and major losses. We have pigeon pea at the highest, that ranges from 40 to 90% of the crops perish due to weeds. Manual weeding process could result in either overspraying of the herbicide or underspraying of the herbicide. Manual spraying can drift and damages neighboring field. For example, in Gujarat's Bharuch district, over 18,000 farmers from 280 villages suffered complete crop failure in 2021 due to herbicide drift. And underspraying is equally harmful, if not more, than overspraying, which could result in 50% of the crop damages. So, what's the solution of this manual weeding process, you may ask? The answer is KAWACH. KAWACH is an AI-powered bot which scan fields, identifies weed with AI, and spot and sprays only where needed. This can cut chemical use up to 90% and replace weeks of manual labor. Businesses and farmers face rising labor costs, increasingly herbicide resistance, and regulatory pressure for suitable practices. Kavach addresses all three simultaneously, with precision agriculture market projected to reach up to $12.9 billion by 2027. Our solution targets a growing demand for smart farming technologies. So now let's get into the technical details of the bot. The bot is equipped with a Raspberry Pi Zero W microcomputer with a V2.1 camera module attached to it. The Raspberry Pi Zero W is attached to a T-bot. What is a T-bot? I'm going to explain in the further slide. And the work of the T-bot is to move the camera to cover all the 1 meter square plot area. After the image is acquired by the Raspberry Pi, the image is going to be compressed by 80 to 90% and sent to the Google Cloud via MQTT protocol, and the image is going to be TLS encrypted. Our AI model, which are we hosting on Google Cloud, is going to be based on Llama, Meta's open source AI model. The main work of AI model is to perform pixel-level wide weed identification and output a JSON formatted file which will include herbicide dosage, herbicide spraying location, as well as which kind of herbicide is to be sprayed. When the JSON file comes back to the Pi, it processes it and controls the nozzle, which is again attached to a gantry plate of T-bot, which is controlled by stepper motors. The nozzle is pulsed with modulated, so it has a variable flow rate. It sprays the herbicide at an accuracy of 5 centimeter based on calculated pixel to distance mapping.
So, as we have discussed about our weed control model, the Raspberry Pi, which after detection also controls the weed with the help of the precise spraying of herbicides. So, there are different herbicides for the control of different kinds of weeds. Like there are narrow leaf weeds with grassy like leaves, there are broadleaf weeds, and for the control of these kinds of weeds, we have herbicides separately for narrowleaf weeds, then separately for broadleaf weeds, and also a combination of herbicide which control both of these kinds of weed. Like for the narrowleaf weed, there are phenoxapropiethyl which control Phalaris minor in wheat, the clodinafopropagil, cyclophobutyl, the phenoxaden which control Phalaris minor, Avinaludoviciana in wheat, The bispyribag sodium, which is the most popular herbicide in rice for the control of narrow leaf weeds, and this is applied as a pre-emergence. Like, coming to the second row, the herbicide for the control of the broadleaf weeds, like the most common here is the 2,4-D sodium salt, which is used to control the broadleaf weeds in various crops. Coming up to the next table, next row, we are able to see that the herbicide here are broad spectrum. It means that they are able to control narrow leaf weed, broadleaf weed, and other sedges at a single time on the same time. Like the glufosinate ammonium here, it is a broad range herbicide which controls the annual and perennial narrowleaf as well as broadleaf weeds. So in this slide, we are able to see and understand that there are specific herbicide for a specific type of weed, and the combinations are also available.
In this 3D model of the prototype, the red blocks represents the Raspberry Pi 02W, which is connected to a T-board engineered for suitable motion across the gantry, so the system can capture consistent images and spray herbicides with accuracy. The Pi will be connected in the middle of the T-board, and the T-board will be flipped over as you can see in the 3D model facing downwards. Now I will show you a quick demo of the prototype that we are working on.
So this is a demo of the prototype that we are working on. This is a Raspberry Pi 0W. It has a V2 camera attached to it, and there is a button. When I press the button, it will click the photo and send it to the Google Cloud for AI processing. It clicked the photo and I will show you on the desktop.
So I will show you the image that it has captured and send it to the cloud for AI processing. The image that it has captured has a unique name. The name depends on the date and the time of the capture. This is the image. The quality of the image varies with the ambient light because I'm using a V2 camera, which is not that advanced. But the final prototype could have a more advanced camera like version 3 or version 4 of the Raspberry Pi Cam. KAWACH will be able to reduce agricultural losses due to weeds from 40% to 15%, which is drastically significant for many farmers. Our prototype currently costs around 8,000 and the final product could cost up to 50,000. Right now we are sending data for processing to a cloud, but we could use Pi 5 for running AI models in it, hence eliminating the requirement for internet and reducing the total time for processing. We could also attach a GPS module which could be used for navigating across the field automatically. India is the largest agriculture-based economy and we don't have a weeding bot, which our current counterparts like China and USA have. Kawach is not only a protector from weeds, but also a protector from poverty for the farmers. At the end, I would like to thank you all for your patience and attention. Thank you.